welcome again. And my name is Xiaoli, and I'm currently a solutions architect working at AWS. And previously, I've been a long time web developer, building both front-end and back-end systems on the cloud. What I'd like to speak about today. Well, first, I want to give an introduction of serverless. Like what do we mean when we say serverless at AWS? And also then I will give a quick overview and an introduction of the two serverless services that we're going to be using in today's hands-on part. And then we will dive into make a serverless backend on AWS. By the way, are you guys able to access this document?
Yes, I'm in.
Okay, great.
Yeah, I have access to.
Thank you. So this is what we will gonna be using later for accessing the temporary AWS environment. This time it will be good for 24 hours. Well, counting from 30 minutes ago. So basically, there is some time you can play around with it after this event also. And okay, so I am gonna start with the part about what do we mean when we talk about serverless at AWS. Serverless has been an industry buzzword for some years, and it actually means a lot of different things to many different people. And at AWS, actually, when we talk about serverless, we generally come down to this 4 key criteria, basically 4 guiding principles. And that's how we define whether something is serverless or not. So first, it means there's no server to manage. That sounds naturally, and which actually means no physical infrastructure, and also no virtual machines that you need to provision or manage. And you don't do OS upgrade, and you don't need to worry about security patches. And you just worry about your application, your business logic. And that's how you can focus on what's the most important part for you. And so you only write the code for what your application is supposed to do, and you don't need to worry about the underlying systems. And secondly, a serverless service should automatically scale with usage. So when requests come or data comes or events come, and the service scales automatically to handle that for you, so that your application, your system can keep functioning properly without your interference, or without that you need to do something to always worry about if you have enough capacity or if you have system bottlenecks. And then this actually brings us to the price model also. Here, because it auto scales, in the resources you consume actually changes over time according to what's really happening to your application. And you will only pay for what you use. That's what we say, pay for value. And you don't pay for idle. So let's say you won't need to pay for some resources that are just sitting there waiting for your users' requests to come. And the last principle, it has to be, it should have high availability and security built in. And in AWS, there's this concepts of regions and availability zones. And regions are AWS global infrastructure in such as Tokyo, US East, US West, and inside each region, there are multiple availability zones, which basically are data centers, which are like in a comfortable distance apart from each other, so that it wouldn't like be brought down altogether by a single, say, disaster event. But also they are close enough together within this geographical region that all the applications deployed there and all the systems there can communicate with each other in a reasonably fast enough speed. And so in the traditional server model, you would need to think about running multiple copies of your application across all these availability zones to realize high availability. And then you would need to do load balancing among them. And probably also you would need to configure the network securities. But in the serverless model, you don't need to worry about that. And all this high availability and security is handled by AWS side. And actually, well, today we will see how to build a serverless backend with Lambda, but serverless actually spans many categories of AWS services. So from the top, we have the compute services. And here we have as serverless, we have AWS Lambda, and we also have AWS Fargate. You use them to run your application code, and we will take a close look at Lambda in a bit. But Fargate, this is a serverless compute engine for container orchestration. And this is compatible with both the Amazon Elastic Container Service, ECS, and also the Amazon Kubernetes Service, EKS. And then in the middle, we have serverless data stores services. Here we have Amazon S3, which is an object storage service. You basically can put anything in S3 and you access it in a key value manner. And then there is a relational database. This we have Aurora Serverless. Aurora is the relational database engine for MySQL and PostgreSQL. And then on the right-hand side, there is DynamoDB. This is the serverless NoSQL key value database on AWS. And then at the bottom, we have a variety of integration services. And on the left, API Gateway is something we will take a closer look and actually use later today. And this is a service that lets you set up highly scalable, secure APIs. It can be RESTful APIs or WebSocket or just a simple HTTP API. And it's very easy to set up. And you can get a running API on the cloud in basically in no time, and this also auto scales. Okay, and on the right hand side, there are queue services, and there is also this SNS service. It can like send email for you or also post messages. Then the whole it can be used to orchestrate your whole your different parts of the system on the cloud, and also it can be used to communicate with other parts of your system, for example, or in your own data center. And then there is step functions. This is a workflow tool and also used for your system orchestration. And then there is also app sync. So these are just part of all the serverless world on AWS. And let's just focus on the simple things that we will try out today. Okay, so Lambda. So when we talk about serverless on AWS, the most important service to understand first is Lambda here. It actually sits in the center of several trends in computing. So first, there is event-driven. This means rather than the imperative model, where you walk through a program executing commands one after another, the event-driven computing model responds to events. It's reactive. And then inside, well, this is as a kind of event-driven computing model, we have function as a service. This is when a service provider offers the ability for you to execute functions or code without worrying about the underlying complexities. And then in the center where Lambda stands in, we have the serverless function as a service platform. So Lambda is here sitting in the center of all these three models, and it handles load balancing and auto scaling, failure handling, and security isolation. And also, as we talked about, you don't have to worry about OS management, patching. And then it provides, it manages utilization for you, and also many other things. So with Lambda at the core of the serverless architectures, it is important to understand, like this is a typical, how a typical serverless architecture works. And so with Lambda in the center, for example, today we will build our service backend application. And so first we need it's event driven, so we need an event source to invoke our Lambda function. And we will use API gateway, which falls in the request to endpoint paradigm. But there are also other possibilities for defining event sources to invoke your Lambda function. This could be, for example, a change in data state. Let's say you have some new records written to your database. This could be, you can then use this as an event to trigger your Lambda function to do something. For example, you get a new user registered, then you can trigger a Lambda to send him a grading email. And then, well, it's also a pretty common pattern to integrate Lambda with S3. And for example, something new file is uploaded on S3, and then S3 will trigger an event that will then be used to invoke a Lambda function to do something. And there is also changes in resource state. So this also could be anything. For example, AWS config is a service that you can define rules for your resources on AWS. And when there's something changed in the resource, let's say, for example, a hacker hacked your system and changed the spec of your EC2, and then AWS config can find that out, and it can issue an event, and then you can define a Lambda to do some emergency actions accordingly. So the Lambda actually currently support 6 languages: Node.js, Python, Java, C#, .NET, and then Golang, Ruby. And also you can define or create your own runtime. And then you can use, then you can write your Lambda functions in whatever languages you like. And then on the downstream, Lambda can interact with other AWS services. And let's say, well, this is S3 or this is DynamoDB. And it can also interact with services that's not on AWS. For example, it can make HTTP calls to a third-party provider. And so basically you have, you can do anything with Lambda, and just think about it like your application code, but you don't need to worry about like deploying it to let's say virtual machine or manage containers, and you just write your application code functions. Okay, we have a couple of new people attending. Welcome, and sorry, I am already in the middle of the introduction part. So later we will use the resources written in this doc to do the hands-on. Yeah, thank you, Jatsi. And yeah, so let's take a quick look at how exactly a Lambda looks. So this is how is a Lambda function structured. The first thing to note is that the Lambda function has a handler. The handler function, this is the function that will be executed when your Lambda function is invoked. Here we have a Node.js example, and the handler function is this exports.handler. And this is basically like an entry point, and you can have a whole other files of like however you like to structure your application code. But this is what really gets executed when your Lambda function is invoked. And the second thing is when the Lambda function is invoked, it receives an event object. And this is the data sent to the Lambda function during the invocation. And you can use it to pass the data that you want Lambda function to handle. For example, with API gateway integration, this could be data sent via HTTP request to the API. And finally, you also will have this context object. This object provides you a number of methods that allow you to interact with the runtime. The runtime information that's specific to that Lambda function. Because when Lambda scales, you actually would have multiple copies of your Lambda function running and handling requests for you. And so this is in the context object, you get metadata about your Lambda function and its execution environment. So for example, that particular request ID and log group, this is a Lambda can send log to CloudWatch, and which you can use to monitor and debug, and a lot of other information. Okay, and next, the integration part. Today, what we're going to be using is Amazon API Gateway. And Amazon API Gateway is a fully managed service. So it makes it very easy for developers to publish and maintain, monitor, and secure APIs at scale. And it can act as the front door for applications to access data and business logic or functionality from your backend services. And it handles all of the tasks involved for running an API for you, such as accepting and processing up to hundreds of thousands of concurrent API calls. And it can manage traffic for you and also handle authorization and access control and monitoring. And also it provides API version management. And today we will be building a really simple serverless backend using the two services I just introduced. This, from the client's point of view, we will have the API gateway to receive and process their requests. And then API gateway will trigger the Lambda function. And this part we will not build today, so that's why the dotted line. Lambda can interact with other AWS services, and here as an example, it can, for example, read or write from to the Amazon DynamoDB, the serverless NoSQL database. Okay, so let's see, is anything until now? Do you guys have any questions? Anything that you would like to comment?
Is this Amazon API Gateway a part of the free tier account?
This is, well, today we will use temporary account. This will be completely free. You won't need to give you won't need to give your credit card. You just use it, and then it will go away after like I set this time to 24 hours, which starting like 1 hour ago. So after that time, everything in there will go away.
Yes, thank you for that. But my question is, like, after 24 hours when it's gone, and if I would like to use this service through my AWS free tier account, I don't see it in my free tier account. Is this, am I missing something? That's why I'm asking.
There is definitely free tier. You can see it in API Gateways pricing page, and for the free tier, 1 million API calls is included, and messages and connection minutes for WebSocket is also included. So this is all up to the first 12 months. So there's definitely enough, I'd say, in the free tier for you to just experiment.
Okay, awesome. Thank you. Yeah, I'll look into this one.
Great, thank you. By the way, for Lambda, we also have something similar. also, the first 1 million requests per month is free. So yeah, please do play around and experiment in your free first 12 months period. And build different things.
Sure. Thank you so much. Yeah.
Cool. Thank you. Anything else?
Yeah, I had a question.
Hi. Yes, please.
Thanks for doing this presentation, Xiaoli. This is very informative. So if like for the database, say, so for Lambda, you said there can be multiple instances. Do they have, do they each have their own database, or do they share a database?
It will, if think about it, you can think about Lambda as your, I don't know if you use container, but it would be similar. So basically the compute layer and the data layer should be separated. And Lambda is stateless. And so multiple Lambda, you tell Lambda what database they should access.
Okay. I was just wondering how it, yeah, so thank you for, because I was going to ask about state next. And because usually with databases, like if one's reading and one's writing, you don't know if the data is, you know, consistent or good. So I guess Amazon or AWS handles that somehow. I'm just wondering, yeah.
Well, for state, you mean, I mean, it's actually the same as other, when you're using other compute services. If you use virtual machine, you will also scale to multiple instances when your traffic goes high. And in that case, well, generally, when you handle, let's say, application state, that should be in the separate layer. So all your compute instances should be stateless.
Okay, but what about like database consistency? So I guess it's a separate layer, so they all write to one database.
Right, and you need to handle that actually. So you need to, well, it's actually the same as database. You need to consider data consistency when you use database. So no matter you use serverless or you use servers, you should you should have the consistency in mind building your applications.
Okay, thank you.
Thank you. Okay, so I guess we just dive into some hands-on time. And this is how you can access this time the temporary AWS account. So you go to the dashboard here and enter this event hash. And then you can use email one-time password and to receive the confirmation code. And then wait for the code to reach your mailbox. Okay, mine already. Okay. And sign in. And you can access AWS console. I am already signed in with another account. So I will just keep using that one. And so let me know when you reach this AWS console homepage. Thank you. So does anyone has any problems, or you guys just want to watch? That's also totally okay. Right. So we will build starting from creating a Lambda function, and let's go. To first go to the Lambda console. And create a new function. And there are also a lot of blueprints provided, which is easier to get started when you have more complex use cases. There are a whole lot of them. And especially when you need to integrate with other AWS services, it's very convenient to use blueprints. But today we will just also from scratch, and let's call it resources, because that's what we are going to build. By the way, I think I didn't mention what exactly are we building for today. We have this Frontend that was a collaboration from a hackathon with Wonderful Code Frontend team, and the Frontend track folks created this beautiful React frontend, and in the resources part, it's currently fetching a static data in the app, and we will build an API to serve the data dynamically today. And so we will do it by creating our Lambda function, and we use Node.js, and all the other things we don't need to worry about right now, and just leave them as is and create. Okay, and then we go to, and we are in our in the console of our function, and we already have a starting template here, and this basically just sends back HTTP status 200, and the body just hello from Lambda, and we can Oh, are you using one of the Are you using your own account, or are you using the event engine account?
I'm using the one that you gave us. It shows the function already exists. I tried to create a new function, and it shows it already exists. Should I change the function name, or I'm using the same name as yours? Is it globally unique?
It shouldn't matter, but okay. Yeah. For now, then just try another a different, slightly different function name. Maybe because we are using the same event engine accounts.
Yeah, now it created a new one. I think it should be globally unique. Thank you.
Okay, and then we can just copy everything from this data JSON. And define our define what we want to send back. And put it in the body. And we deploy. And we can test it, but it doesn't matter this time what event we send it, because we don't check the event, we just always send back the JSON. And the test result is this is the response our Lambda will send back. So that's basically the most simple Lambda function that does something that we have just created. And is everything okay with that part? Okay. And now we can create our API gateway. We can do this by going to the API gateway console. And let's start by building a REST API. We create a new one. And then we are in the resources because we are building a RESTful API. And we create a resource. We want to enable CORS so that our front end can fetch the API from anywhere. And we define a get method. integration type, we choose Lambda function. And we select our Lambda function here. Oh, I definitely think we are in the same account. Okay. And we can test it. And our resources is sent back from the body, in the body. And we actually also need to enable CORS here. So that we can get the allow origin header, and so that our front end of browser wouldn't complain. Okay, any questions? Everything's working for you? Okay, let's deploy it on a new stage. Let's say dev deploy. Then we have an invocation URL created for us. So the root, we don't want to expose it, but sources. We can get the resources we defined through the API gateway, and this is what the Lambda actually is sending us back. And then in here, in our front-end code, we don't need this static resource list anymore. And we copy paste the API URL. That's the API running on the cloud. And it should fetch data from our API gateway and then parse the resources in the body that we defined. Yeah, now we have dynamic data coming from an API running on the cloud. Okay, so it should mean that everything works for you as long as you can come to this step. Yeah, it looks really easy, right? Okay, so any questions?
I don't have questions about the I don't have questions about the material or like Lambda. I don't know, is this the end of the presentation or is there more? Because I have some off-topic kind of questions.
Yeah, this is I think I need to close in like 5 minutes, and this is the end of the session.
Okay. Yeah, this is very easy. Like you can create an API backend so quickly,
Right.
so
Yeah.
easily. Yeah. Because I know a little bit of Ruby on Rails,
Mhm.
and we would have to like it was sort of easy to make a backend, but not this easy. Like it would take a little, a couple more hours to like
Mhm.
create a API backend or endpoint. So
Mhm.
my question has to do with being a AWS solutions architect. Can you like talk more about that role? And because that's a really interesting role. Like I'm really curious like what that
Oh, okay. Oh, that's actually topic for maybe a career session later.
Okay.
But basically, what I do day to day, there are different kinds of solutions architect, and I am a generalist, and there are also specialist solutions architect. So the generalist, you will have a broad understanding of nearly all the AWS services, and day to day you support AWS customers to use AWS better, and also you contribute to community to help more people to learn and use AWS. And the specialists, they will be more focused on one or two areas. Yeah, I think Jesse just post a career panel tomorrow. I
Yeah.
don't know. There's probably also a solutions architect there.
Okay.
Yeah, definitely check that out.
Okay. So do you help clients or customers kind of build out like a system using these kind of blocks?
Yeah,
Into like
sure.
okay.
I definitely help them on architecture designs, but we would not really write production code for the customer, because that would be another team's, like we have professional services team, and that team can really work like a consultant and to develop applications and write code. So it's like different similar job family, but different responsibilities.
Okay. And did you take any of the certification exams? Like, do you need like the entry level one where you like kind of and then build up, or is it?
Yeah, the associate solutions architect certificate definitely everyone needs to have.
Okay.
What the others is like more like what you want to focus or develop.
Okay. Sure.
Okay. Yeah, thank you very much. And I think I will give it to Jiaqi for the closing. And thank you very much for attending.
Yep, thanks everyone for attending. Thank you, Xiaoli, for the presentation. And we'll see you all next time. Bye.
Thank you. Bye.